Hello, this is Ash Coop and this is assignment 4.5. So this assignment's on quantitative data analysis. Quantitative data, is a very objective way of collecting numerical data sets and can be made more externally valid by using large sample sizes. Quantitative data analysis is usually associated with gathering numerical evidence to either accept or reject a hypothesis you have formulated at an earlier stage of your research project. There are some benefits of quantitative data analysis. One of these is that it can be compared to normative data. Normative data is typically secondary data collected from a large sample size that can be generalized to a wider population. Another benefit of quantitative data analysis is that it allows comparison between populations based on age, gender, etc. For example, collecting sit and reach flexibility scores on female British gymnasts and then predictions to be made on collecting them the same data for males and compare them. Another benefit is it can allow predictions to be made on sport performance, for example, recording the data of vertical jumps in relation to the height and plotting a correlation graph. After you do so, it can allow you to predict that if an individual is a certain height, you can predict how high you think they might jump. Another benefit is that you can compare the data set between different sport performers. For example, if we collect flexibility scores on gymnasts, we can use this to compare the flexibility to sprinters, for example. Furthermore, another benefit is that you can identify trends in health by, for example, you could compare the difference in red blood cell count in blood between athletes that take part in high vigorous intensity activity compared to those take part in activities that are low or moderate intensity. Another advantage of quantitative data is that it allows you to compare an effect of an intervention to the experiment/research. For example, testing beetroot juice on the flexibility of British gymnasts. Test the flexibility of a group of female gymnasts, collect their results, and then give the same female gymnasts some beetroot juice and test their flexibility scores after a period of time, and then collect results and compare the results of when they had beetroot as the intervention and when they didn't. Having or collecting some quantitative numerical data from a series of practical fitness tests. There are 4 stages in organizing the data received to make them more manageable. However, before you step into organizing the data, you must make sure that the method of collecting the data was robust and valid by having correct and rigid protocol to collecting the data. The 4 stages of organizing data are through a range of the data set, putting in rank order, having a data in a simple frequency distribution table, and finally a grouped frequency distribution table. This is the stages of organizing data. First of all, there's the range. The range is simply the difference between the highest and lowest data set. Subtract the lowest data set from the highest. For example, here's a data set of 5 young British gymnasts sit and reach test, and the highest score was 56 and the lowest was 35. So simply subtract 35 from 56 to get you 21. There's a variation in results. That's what range shows you, and a large range shows that some have good fitness and some have bad fitness, and small range means all individuals are around a similar stage of fitness. Next is rank order. Rank order is simply placing an ordered list from the highest to the lowest. Rank order is used when n is less than 20 to avoid extensiveness of the list. For example, scores of young British female gymnasts flexibility scores from the sit and reach test, as you can see. If the data sets are, for example, 45, 52, 58, 49, 55 in centimeters, then the rank order can just be arranged to 58, 55, 52, 49 or 45, showing the rank order of their data set from the highest to the lowest. Next is simple frequency distribution and cumulative frequency. Simple frequency distribution is when n is larger than 20 and the range is less than 20. A frequency distribution table is used with 2 columns, one for raw data and another for the frequency. Cumulative frequency is then the total of the frequency added up as you go along. For example, the table I have I have used shows the execution scores given to young female British gymnasts during their routines. As you can see, next is grouped frequency distribution. Group frequency is when n is greater than 20 and the range is greater than 21. A grouped frequency table consists of a table with one column which has raw group data and the other column has the frequency. The table should consist of approximately 10 to 20 groups, ideally 15 to avoid extensiveness. If groups are more than 20, widen the range of the group intervals to shorten them. Intervals in groups are usually calculated by the range divided by 15. For example, the data I have shown on my table shows the vertical jump of some female British gymnasts in millimeters. Next we look at central tendency. Central tendency is having one value that represents the whole data set. This can either be the mean, mode or median. So with the mean is the average of the data set. So if you add all the data values in the data set and divide them by how many there is, for example, if you calculated the mean of the sit and reach test of these female British gymnasts, as you can see using the data set that I collected, you add them all together, which equals 439, and you divide by 7 because there's 7 different data sets. And that value, which is 62, is the mean of the data set. The benefits of the mean is that it includes every single data value of the data set. It also used often and has close relation with standard deviation in showing dispersion of the data. The limitations of the mean are that it is susceptible to influence of outliers, especially if the data set is small. It doesn't always make sense as when calculating the mean of how many children there are in a certain area. If, let's say, your mean is 5.7, as that doesn't make sense because you can't have a decimal amount of children. The mode is the most common data value in a data set. For example, if you calculate the mode execution score given to some young British female gymnasts during their floor routines with the data set as shown, the mode would be 9, as is the most common value. The benefits of mode are that it can be graphically determined from a frequency graph. It also can be used for nominal categories such as stages of blood pressure. The mean and median can't show this. The limitations of the mode are that there can be more than one mode or value. Also, continuous data is less likely to have a mode or value. Next is the median. The median is the middle value of the data set after it's been arranged from the smallest to the largest. There are also very different ways of calculating the mean depending on if your data set is odd or even. If the data set is odd, as you can see by the first data values of young female British gymnasts vertical jump scores, if the data set is odd, you do a simple calculation of n plus 1 divided by 2, n standing for the data values in the data set. So in my example, the vertical jump test scores of young female British gymnasts would be 7, which is the odd number, plus 1 gives it 8, and then divided by 2, which is 4. So the fourth value, make sure you don't make the mistake of 4, of you saying 4 is the median. It will be the fourth value in that data set that will be the median. If the data values in the data set are even, then you will have 2 medians. So you simply add them together and divide by 2. In the data set as shown, the 2 medians would be 48 and 45. This is after they've been arranged from smallest to largest, so I would add them together and then divide by 2, which gives you 46.5. The benefits of using the median as a central tendency value is that it is less affected by outliers. So for example, if you change the 42 data value in the even vertical jump to 95 as an outlier, this still doesn't affect the median. Another benefit is that it's good with ordinal data. Some limitations to the median is that it is slow to calculate the median with large data sets. It also isn't great with small data sets that have big variations in the data values. E.g. a data set that has 4, 5, 7, 90 and 95 as the data set. The median would be 7, but a more realistic median would be around 55. Next is dispersion. Dispersion is having one data value that represents the dispersion of the data. This can either be the range, interquartile range, or the standard deviation. First of all, range. Range is the value you got from taking the smallest data value in the dataset from the largest. For example, the range of the resting heart rate of young female British gymnasts would be 83 minus 68 in that data set as given, which gives you 15 as the range. The benefits of using the ranges to show dispersion is that it is easy to compute and understand. It also best for symmetric data with no outliers. Some limitations are that it doesn't use all of the data values in the dataset, only extremes. It also is very much affected by outliers. Next is the interquartile range. The interquartile range is the first quartile taken away from the third quartile, and it shows you how much the mid or 50% of your data set varies. And the median divides the data set into two halves. The first quartile divides the bottom half of the third quartile. Third quartile divides into the top half. The median divides the data set into two halves. The first quartile divides the bottom half, and the third quartile divides the top half. To calculate the interquartile with the scores received from 15-meter sprints of young female British gymnasts, as the data set is odd, it shows you. You put the data set in rank order and get a median, which would be 5. You then put brackets either side of the median in the data value to help you spot the first and third quartile. So the first quartile would be 3, 4, and 4, and the third quartile is 5, 6, and 7, leaving you with 5 as the median. You then select the median of the first quartile and the third quartile and subtract them. So the median of the first quartile will be 4, and the median of the third quartile is 6. You then subtract the first quartile median from the third quartile, so 6 minus 4, which equals 2, as the interquartile range of this data set. To calculate interquartile range with the scores received from 15-minute sprinters of young female British gymnasts when their data set is even, you put the data set in rank order to begin with, and then you draw a line in the center of the data, so the line will be between the third 4 and the first 5 in that data set. You then put brackets around the data set either side of the line you made in between the data set, as shown there using an exclamation mark. You then select the median of both the first and third quartile. So the median of the first quartile is 4, as shown, highlighted, and the median of the third quartile is 6, as shown, highlighted as well. You then subtract the median of the first quartile from the median of the third quartile, so 6 minus 4, which equals 4. 6 minus 4, which gives you 2 as the interquartile range. The benefit of the interquartile range is that it's good for ordinal data. It ignores extreme values, unlike the range. The limitations are that it is harder to calculate and understand the range. It also doesn't use all the data values in the set. Next is SD, or standard deviation. Standard deviation is a number that indicates how many each of the values in a distribution deviate from the mean or center of the distribution. The benefits of SD are that there are the same units of measurement as the value. Standard deviation is also useful in theoretical work and statistical methods and inference. The limitations of SD, or standard deviation, are that it is hard to calculate manually.